All right, hello. We are going to move on to the next part of 10.2. So we are still talking about simplifying radicals, but what we're going to find is that oftentimes we get in the situation where we need to multiply radicals, and then after we multiply the radicals, we want to make sure that they are in simplest form. So that's what we're going to be doing today. So to get started in this, the good news is it is basically the same thing we did yesterday with one extra step in the beginning. So first thing, whenever we're talking about multiplying radicals, we can multiply radicals that have the same index. So the index is going to be this number that's in front of the radical sign. Now, here's the thing. With all of the radicals that we talked about yesterday, there wasn't a number there. So with a radical, if there's not a number there, it defaults to a 2. Now, fortunately for this year, we're only going to deal with square roots, so radicals that have an index of 2. But later on in your algebra careers, you will find that we have cubed roots and fourth roots and so on. So here's how we're going to multiply radicals. So 3 steps. First thing, whenever you're multiplying 2 radicals together, you're going to multiply the numbers on the outside of the radical, and they're going to stay on the outside of the radical. And you're going to multiply the numbers on the inside of the radical. They're going to stay on the inside of the radical. And then finally, you're going to simplify by the cake method or by looking for perfect square factors, just like we did yesterday. So this, like I mentioned, is really pretty simple. So for this first one, if I want to simplify the square root of 3 times the square root of 6, I'm going to multiply the numbers on the outside, which in this case, there are no numbers on the outside. But then I'm going to multiply the numbers on the inside. So I have a 3 and a 6, both on the inside. So it's kind of like the opposite of what we did yesterday, where we broke apart a radical. So this time we're multiplying 2 radicals together and writing them as one radical. So we're going to call this the square root of 3 times 6 is 18. And when that turns into the square root of 18, we would need to make sure that that is in simplest form. So we would either need to cake 18, so we could divide out of 2, we'd get 9. Divide out of 3, we'd get 3. Divide out another 3, and we'd get 1. So we end up with a pair of 3s. Remember from yesterday, pairs come outside. Anything without a pair stays on the inside, so we'd end up with 3 square roots of 2. Or, also keep in mind from yesterday, we could look for perfect square factors. So 18 would be 9 times 2, keeping in mind that that is still underneath the radical sign. And when you take the square root of 9, you get 3. And we cannot take the square root of 2, so it stays the square root of 2. Now, for our second one, I do have numbers on the outside. So since I have a 2 and a 4 on the outside, we're going to multiply both of them together, 2 times 4, and they're going to stay on the outside. That 8 is going to stay on the outside. Now I have a 12 and a 15, both underneath the radical, so I'm going to multiply those together. 12 times 15 is 180, and they are going to stay under the radical. Now the last thing we need to do is to make sure this is in simplest form, which this one most definitely is not. So this is one where I would probably go ahead and just cake 180. So if I divide out of 2, we'd get 90. Divide out of 2, we'd get 45. We could divide out a 5, we'd get 9. Divide out of 3, we'd get 3. One more 3 to finish that off, and we would get our 1. So we end up with a pair of 3s and a pair of 2s. Now remember from yesterday that yes, the pair of 3s comes out and becomes 1 on the outside of the radical. The pair of 2 comes out and comes on the outside of the radical. But this 8 from the beginning is already outside the radical, so we need to make sure we include that as well. Now underneath the radical, I have that 5 that was left over that did not pair up with anything. So then finally, to bring all this together, 8 times 3 times 2 gives me 48 square roots of 5. All right, let's go ahead and let's move on to examples. You can get this glued in at the very end. All right, so for our examples, our first example, let's do the square root of 6 times the square root of 15. Now, like I said for the last one, what you're going to do is you're going to multiply the numbers on the outside of the radical. They stay on the outside. I don't have any numbers on the outside of this radical. So then we're going to multiply these two numbers that are underneath the radical. The 6 is underneath the radical. The 15 is underneath the radical. When I take 6 times 15, I get 90, but they are going to stay underneath the radical. And then once you get to this step, it is the same thing as yesterday. So you would either look for perfect square factors of 90, or you could cake 90. If we were to cake 90, we could divide out at 2. 90 divided by 2 is 45. Divide out a 5, we'd get 9. And divide out a couple of 3s. And that's what the cake for 90 would look like. So we end up with a pair of 3s. So we've got a 3 on the outside. I have a 5 and a 2 that do not have a pair, so they're going to go on the inside. And remember, if there's multiple things left on the inside or the outside, you multiply them together. So 5 times 2 would give me the square root of 10. So 3 square roots of 10 would be your answer. Okay, number 2. Let's say we have the square root of 8 times the square root of 10. Now the 8 and the 10 are both underneath the radical, so we're going to multiply those together. 8 times 10 is 80. But it has to stay underneath the radical. For me, off the top of my head, I'm not thinking of any perfect square factors of 80, so I would probably jump to the cake method. So out of 80, we could divide out at 2. We would get 40. Add another layer. Divide out at 2, we'd get 20. Add another layer. Divide out at 2, we'd get 10. Another 2, we'd get 5. And divide out of 5, we'd get 1. So we end up with a pair of 2s. And another pair of 2s. So remember, we have on the outside 2 times 2, which is 4. And left on the inside, we've got that 5. So the square root of 5. Okay, let's add to this a little bit. So number 3, let's say we have the square root of 3 times negative 4 square roots of 8. So you're going to take any numbers that are on the outside of the radical. Now for this one, really the only number that's on the outside of the radical is that negative 4. So I've got a negative 4 on the outside of the radical. Underneath the radicals, I have a 3 and an 8. So 3 times 8 would give me 24. And then we would need to simplify that 24 if we were to go with the perfect square factor method. The perfect square factor that goes into 24 would be 4, and it would be 4 times 6. So we're taking the square root of 4 times 6. Now when you take the square root of 4, you get 2. But keep in mind, we had a negative 4 that was out there already. So we're going to take negative 4 times 2, which is negative 8. And then still underneath the radical, I have this square root of 6 that I could not take the square root of. So negative 8 square roots of 2 would be your answer. Okay, number 4, let's say we have the square root of 20 times negative 3 square roots of 5. Kind of like the last one, the only thing on the outside of the radical is that negative 3. So we'll put that negative 3 on the outside. Underneath the radical, I have 20 and 5. So 20 times 5 is 100. Now, if you wanted to, if you're just dead set on caking, you could totally cake 100. But please, please, please be on the lookout for these perfect square factors, because you can actually just take the square root of 100. The square root of 100 is 10. So all you have to do for this one is take negative 3 times 10, which is negative 30. So our answer is just negative 30. Okay, number 5. Let's throw some variables in here. So let's say we have the square root of 4x times the square root of 12x cubed. Now you can, if you would like, to go ahead and be on the lookout for those perfect square factors. But what I think is simpler is, instead of dealing with these two separate radicals, I would go ahead and multiply them together, turn them into one radical, and then simplify that one radical. So underneath the radical, I have 4x and 12x cubed. So if I do the numbers first, 4 times 12 is 48. X times x cubed is x to the 4th. Keep in mind that is still underneath the radical. So I'm looking at 48, either thinking of perfect square factors of 48, or thinking we're going to cake 48. If I were to cake 48 divide out of 2, we'd get 24. At 2, we'd get 12. A 2, we'd get 6. A 2, we'd get 3. And then a 3, we would get our 1. So I end up with a pair of 2's and another pair of 2's. So on the outside, 2 times 2 gives me 4. I'm going to leave a little gap for the variables. On the inside of the radical, that 3 did not pair up with anything, so I've got a square root of 3 left over. Now remember from the variables from yesterday, x to the 4th is x times x times x times x, still underneath the radical. And you do the same thing with the variables that you did with the numbers. You would pair up the variables. And if I have x to the 4th, I would be able to make 2 pairs. So on the outside of the radical, we're going to have 4x squared and then square roots of 3. Let's try another one of those. So we have the square root of 3n to the 5th times negative square roots of 5n cubed. Now if I look at what's on the outside of the radical, the only thing on the outside of the radical is that negative. So we're just going to keep our radical negative. Underneath the radical, I have 3n to the 5th and 5n cubed. So 3 times 5 is 15. N to the 5th times n cubed is n to the 8th. Now, if you were to look at 15, and whether you're thinking of perfect square factors that may go into 15, or if you were to try to cake 15, you're not going to get anywhere. 15 cannot be broken down if it's underneath the radical. So what happens here is that 15 just stays underneath the radical. But that n to the 8th, think about writing 8 n's and how many pairs you would be able to make. So pairs out of 8, you would be able to make 4 pairs. So we're going to have an n to the 4th on the outside of the radical. So negative n to the 4th, square roots of 15. All right, 2 more just with a little bit bigger numbers here. So number 7, let's say we have the square root of 28 m squared times 4 square roots of 35 m cubed. So once again, we're looking for the numbers on the outside. For this one, the only number on the outside is that 4, so we've got a 4 on the outside. Now underneath the radical, if I multiply the numbers, we would take 28 times 35 and we would get 980. And then m squared times m cubed would be m to the 5th. Now, you could, if you wanted to, go to all this work of finding perfect square factors of 980, but especially when these numbers get bigger, I would probably just go ahead and cake these. So for 980, it is even, so I'm going to divide out at 2, and we would get 490. I could divide out at 2 again, and we would get 245. I notice that it ends in a 5, so I am going to go ahead and divide out a 5, and we would get 49. And then we can divide out a 7 and one more 7 to finish that one off. So we end up with a pair of 7s and a pair of 2s. So on the outside of the radical, we have the 4 from the beginning. We have a pair of 7s, and we have a pair of 2's. I'm going to leave a little gap for the variables. And underneath the radical, we just have that 5 that's left over. Now, if I finish this one up, if I look at the m to the 5th, if you think about having 5 m's being multiplied together, you would be able to create 2 pairs out of that, but there would still be 1 left over there at the end. So your final answer, multiplying those numbers together, should give you 56 m squared square roots of 5m. All right, and last one. Let's try 7 square roots of 20 m squared times negative 9 square roots of 45 m cubed. Okay, once again, like the last one, let's go ahead and let's multiply the numbers on the outside. So 7 times negative 9 would give me negative 63. For the numbers underneath the radical, if I take 20 times 45, I would get 900. And then m squared times m cubed would be an m to the 5th. Now, when we get to the when we get to the caking part, I'm telling you, I would definitely be on the lookout for these factors of 100, because 100 is usually an easy one to see. 100 is a perfect square factor. I could break down 900 into 100 times 9. And guess what? If I take the square root of 100, I get 10. And if I take the square root of 9, I get 3. So what I have is on the outside, I have a negative 63. I have a 10. And I have a 3. If you multiply all of those together, you get negative 1,890. And then we just have to figure out the variable part. So m to the 5th, I can make 2 pairs on the outside, and then I'm going to have 1m left over on the inside there.